Alright, the topic here is limits at infinity. So, before we do these examples, I need to show you these things. Make sure that you know about the absolute value. Now, if x is a positive number, you need to know that square root of x squared is always equal to the absolute value of x. That's by definition. And since x is positive, absolute value of x will be equal x, whatever x is. Think of x as 2 or 3, so you're going to get a 3. Now, assume that x is a negative number. Then, same thing, square root of x squared is always equal absolute value of x. But since x is a negative number, we need to multiply it by another negative, by negative 1 to make it positive. Think of x as negative 3. Think of this as negative 3. So absolute value of negative 3 is 3. How did we get the 3? It's the same thing as minus negative 3. Right? Which is positive 3. So we need to know this. What else? We also need to know that square root of a over square root of b, this is the same thing as square root of a over b, before we can do these examples. Now, of course, when we do this, we automatically assume a is positive number and b is positive number, right? Alright, so let's do example 1. So, same thing like the previous examples. Let's call these first. We did 14. So let's call this example 15, and this is example 16. Alright. So same thing, we need to divide, since the highest degree is x squared. Actually, we want to divide by x squared, but we want to divide inside the x squared. So this is what you do. So what we do here, limit as x approach infinity, you'll see, this is just a trick. Every time you have a radical, this is going to be the trick. So what we do, we divide by square root of x squared. In other words, our intention to divide by x squared inside a radical. By square root of, x squared. So same thing, we do the same thing for the numerator. We have to divide by square root of x squared. Whatever we divide the denominator by, we have to divide the numerator by. Right? Now, why do we do this? This is why we're doing it. This is equal limit as x approach infinity. So let's start with the denominator. The reason why we want to use this property. Now, this is going to be equal square root x squared plus 3 over x squared. Right? Now, let's not do the top yet. Now, this is equal, and the reason why we do this is going to be x squared over x squared plus 3 over x squared. Of course, the limit as x goes to infinity. And then our goal is, I'm just going to do the denominator first. Our goal is to simplify this. So we get 1 plus 3 over x squared. So it's almost whatever the previous examples we did. Now let's go back to the numerator. Now here we have a problem. What is square root of x squared? And this is why I did these definitions right here. X approach infinity. Positive infinity means, if x approach positive infinity, means we need to use this property. So we're going to get an x. So square root of x squared becomes x. So this is 2x over square root of x squared becomes x. Now you'll see next example we're going to get a negative x when we do example 16. Now here we simplify the x with the x. We'll get 2 as x approach infinity. Same thing here, we get a 2. Now we know this is going to go to 0. So the answer will be 2 over square root of 1, which is 2. And that's the answer. Now let's do example 16, and you'll see the difference between 15 and 16. when x approaches negative infinity. So everything will be the same. This is going to be equal limit of 2x over square root of x squared over square root of x squared plus 3 over square root of x squared. So we divide it by square root of x squared both sides. Then we come here and we say limit as x approaches negative infinity. Now the denominator is the same, so you get x squared plus 3 over x squared. Right, we're just using this property again. And then here you get 2x over, and this is where there's a difference, square root of x squared. X approaching negative infinity means x is less than 0, so we use this one, so we get minus x. So this is going to be minus x. It's the only difference between number 15 and 16. So we simplify x with x. Now we get limit, so we get minus 2 for the numerator, and then this is going to be x squared over x squared plus 3x squared. Radical as x approach negative infinity, which is equal limit as x approach negative infinity minus 2 over. Now simplify x squared with x squared. You get 1 plus 3 over x squared. This goes to 0. And you get minus 2 over square root of 1, which is negative 2. See the difference between example 15 and 16? So that's it for this example.